So we are going to talk now a little bit about this thing called two-way tables. Now by that, it's just a way we can represent our results from an experiment or some data that we've recorded where there's like two options. So here's an example. 50 people we surveyed to ask them if they drank tea or coffee. So let's think about this for a second. What are some of the possible responses or answers that they would give us to this question? Well, first of all, they could drink tea but not coffee. So they might be tea drinkers, but they don't like coffee. That would be one option. Okay. A second option might be the other way around. Well, they drink coffee, but they don't like tea. Can you think about what the third and the fourth ones might be? What if they drink both? Right? Sometimes they like a cup of tea, sometimes they like a cup of coffee, and then you're going to get some people that just don't like either, so they don't drink tea or coffee. There are the only four options because there's only two possible scenarios that we've got here in our question. That we're asking about tea and we're asking about coffee, so they could drink one or the other, drink both, or they could drink neither. We can represent that now in a two-way table. Here are some numbers. I've just made these up. Let's say from our 50 people, these were the responses we got. 6 people drank tea but not coffee. 12 drank coffee but not tea. 27 drink both, and 5 of them can't stand either, and they don't drink either of them. Let's put it into a table. Let's draw this up over here a little bit neater. Here's what's going on. Let me explain this a little bit. I've just got, because there were 4 options, so I've drawn up a table here that has 4 separate boxes. This column represents all the people that drink tea, and this column represents the people that don't drink tea. Going horizontally, my other option was coffee. So I have tea across here, coffee going down this way. They either drink coffee, which is this row, or they don't drink coffee. Okay, so let's go through each of these boxes and see if we can take some of these numbers and transfer them across. So let's have a look. This box here, it's the intersection of people who drink coffee and drink tea. Okay, it's in this column, it's in the drink tea column, and it's also in the drink coffee row. So it's like think of a spreadsheet, it's like a cell where these things meet. So let's have a look at our data. How many people drink tea and drink coffee? Well, when I have a look across here at my numbers, I can see 27 people drink both. So these are the people that drink tea and they drink coffee. Let's go to the next box, this one here. Don't drink tea. Okay, because it's in the don't drink tea column, but it's also in the drink coffee row. So they don't drink tea, but they do drink coffee. This is the intersection of those two things. How many people drink coffee but not tea? Having a look here, it's this row in my data. There's 12 people. Let's go to the next one. This box here, it's in the drink tea column, but in the don't drink coffee row, where those things intersect. So we're looking for people who drink tea but don't drink coffee. That would be these 6 people here in my data. They drink tea but not coffee. There's 6 of them. And finally, the people in the don't drink tea column and the don't drink coffee column. So the people who don't drink either, and that are these 5 people here. Right? So I've now visually put these together. And importantly, if I add them all up, they should, and they do, add up to 50. Why? Because there were 50 people in our survey originally. Okay, so if I add these 4 numbers together, I should get 50, which represents everyone who was surveyed. Now we can take this data and answer some probability questions from it. If someone was just randomly selected from my group and I ask for their response, what's the probability that they don't drink tea or coffee? So hopefully you can remember from our probability questions. Well, first of all, let's find those people. It's this box here, isn't it? They don't drink tea and they don't drink coffee. They don't drink tea, they don't drink coffee. It's these 5 people. The probability, though, of not drinking tea and not drinking coffee, and we wrote this as P, and I could write it in brackets, just not tea or coffee, just something to identify what probability it is I'm working out. Hopefully you remember that the probability is the number of successful outcomes divided by the number of possible outcomes. So it's 5 successful outcomes. In other words, there's 5 people who meet this criteria out of the total number of people, which was 50. I can simplify that down because there's a common factor of 5, fits into both. These are equivalent fractions. Or you could just put it straight in your calculator. You could just go 5 divided by 50. You're going to get 0.1, which is the same result anyway. So we've taken our two-way table and we've used it for a probability question. What about the one last question? What's the probability that they drink coffee? Now, I have to think carefully about this one. How many people in my two-way table do drink coffee? Okay, well, there's these people. Okay, so these people drink coffee, but they don't drink tea. But and they do drink tea, so they're in this box here. But they also, I've got to consider this one, don't I? Because this is everyone who's in the row here that represents the drink coffee row. So these people drink both. These people drink coffee but not tea. And the question says just how many people, what's the probability that they drink coffee? So that they are in one of these two boxes. So I have to add these numbers together. And when I add them, I get 39. So there's 39 successful outcomes out of the 50 possible. So the probability is 39 over 50. And that's how we can create a two-way table and use it to calculate some probabilities. Well done.